Imagine discovering evidence so unexpected that it forces scientists to rethink everything they thought they knew about the universe. What if the most advanced space telescope ever created has revealed observations that challenge our understanding of how the cosmos began? For decades, astronomers believed the story of the universe was becoming clearer with every new discovery. But the James Webb Space Telescope has delivered observations that have sparked intense debate and raised questions that researchers are still struggling to answer. Far beyond the reach of ordinary telescopes, Webb was built to capture light that has traveled across billions of years. Every image it sends back is like opening a window into the distant past, allowing humanity to witness galaxies that existed shortly after the universe began. Instead of confirming every prediction, however, some of its discoveries have surprised even experienced astronomers. Among Webb's earliest observations was a faint golden object that initially appeared unremarkable. As researchers examined the data more carefully, they realized they were looking at one of the most distant known galaxies ever detected. Its light had traveled for more than 13 billion years before finally reaching the telescope. The surprise wasn't simply its distance. According to many existing models, galaxies from such an early period of cosmic history should have been relatively small, chaotic, and still in the earliest stages of development. Instead, this object appeared unusually bright, surprisingly organized, and far more massive than expected. Its existence immediately raised difficult questions. How could a galaxy become so large in such a short amount of cosmic time? Did stars form much faster than scientists predicted, or are current models missing an important piece of the puzzle? Researchers around the world began examining every possibility, searching for explanations that could fit the evidence. The mystery deepened when Webb continued surveying other regions of the sky. Instead of finding just one unusual galaxy, it identified several more with similar characteristics. Each new discovery added another challenge to long-standing theories about how galaxies formed and evolved during the universe's earliest epochs. Rather than proving established ideas completely wrong, these observations suggest that the young universe may have been far more active and efficient at building galaxies than previously believed. Some astronomers are revising simulations, while others are exploring entirely new explanations that could account for these unexpectedly mature structures. As additional data arrived, another remarkable pattern emerged. Certain distant galaxies appeared to contain an exceptionally high percentage of their material in the form of stars. Compared with nearby galaxies, where large amounts of gas and dust remain available for future star formation, these ancient systems seemed unusually efficient at converting raw material into brilliant clusters of stars. Such findings have inspired lively discussions throughout the scientific community. Some researchers believe these galaxies experienced extraordinary bursts of star formation, while others argue that our understanding of conditions in the early universe is still incomplete. Whatever the explanation, Webb is providing evidence that the first few 100 million years of cosmic history were likely far more complex than anyone imagined. Every new observation reminds scientists that the universe still holds countless mysteries. Instead of delivering simple answers, the James Webb Space Telescope is revealing a cosmos that is richer, stranger, and more fascinating than previous generations ever expected. Each image encourages astronomers to refine existing theories, challenge old assumptions, and continue searching for a deeper understanding of how everything around us came to exist. And this is only the beginning. As Webb continues looking farther into space and deeper into cosmic history, its future discoveries may reshape our understanding of the universe in ways that no one can yet predict. The deeper scientists examined Webb's observations, the more they realized that understanding the universe requires more than simply looking farther away. It also means understanding how space itself behaves. One of the most fascinating concepts in modern cosmology is that the universe is expanding, carrying distant galaxies away from one another as space stretches over time. This expansion creates an extraordinary situation. Extremely distant galaxies can appear to recede faster than the speed of light, not because they are breaking Einstein's laws, but because the fabric of space between us and those galaxies is continuously expanding. Although this sounds impossible at first, it is one of the accepted consequences of modern cosmology. There is also a limit to what humanity can ever observe. Light travels at a finite speed, meaning we can only see regions whose light has had enough time to reach Earth since the universe became transparent after the Big Bang. Everything beyond that observable boundary remains hidden from direct view, leaving scientists to wonder what lies farther beyond. The James Webb Space Telescope is helping researchers explore this visible frontier with unprecedented detail. By detecting incredibly faint and ancient light, it allows astronomers to investigate some of the earliest chapters of cosmic history. Every new observation pushes the limits of what can be studied, offering clues about the universe's infancy. Instead of solving every mystery, however, Webb has uncovered new puzzles. Some distant galaxies appear larger, brighter, and more chemically evolved than many theoretical models predicted. These discoveries do not necessarily overturn the Big Bang theory, but they suggest that galaxy formation in the early universe may have happened faster or differently than expected. As these findings accumulate, cosmologists are revisiting long-standing assumptions. Computer simulations are being updated, new models are being proposed, and researchers are exploring whether unknown physical processes played a role during the universe's first few 100 million years. One of the greatest strengths of science is its willingness to change when evidence demands it. Throughout history, major discoveries have refined humanity's understanding of reality, replacing incomplete explanations with more accurate ones. Webb's observations may represent another important step in that ongoing process. The telescope has also revealed countless gravitational lenses, where massive galaxies bend and magnify the light of even more distant objects. These natural cosmic magnifying glasses allow astronomers to study galaxies that would otherwise remain invisible. Every gravitational lens provides another opportunity to peer farther back into cosmic history than ever before. Meanwhile, researchers continue investigating the invisible influence of dark matter, the mysterious substance believed to make up most of the universe's matter. Although dark matter cannot be observed directly, its gravitational effects shape galaxies, galaxy clusters, and the large-scale structure of the cosmos. Webb's precise measurements are helping scientists test new ideas about how this unseen material influenced the formation of the earliest galaxies. With every observation, the universe becomes both clearer and more mysterious. Each answer seems to reveal several new questions waiting beyond it. Rather than closing the book on cosmology, the James Webb Space Telescope has opened an entirely new chapter, one filled with discoveries that may transform our understanding of the cosmos for decades to come.